Hi everybody, this is another fun rookie video, and this video number 16 of the former VC-450 HOVERTHINGS camouflage quadcopter. And I say former because it is not longer a VC-450 quadcopter. Now it is the VC-550 quadcopter. Since I did upgrade it, I put the arms for the 550. And now there's a larger quadcopter. Okay, so this quadcopter, when it was a 450, it was flying nice and everything, and went through certain issues with electronics, and I took the opportunity to do a complete overhaul on the aircraft and make the aircraft larger and put new electronics in there. Okay, so that's why now it's the VC-550. So this video was supposed to be the maiden flight video, not the maiden flight because this aircraft flew already, but the maiden flight because now it's almost like a new aircraft right now. I got new motors, new ESCs, new flight controller, new power wiring system. Pretty much this aircraft, it was completely overhauled from top to bottom. So it would be a remainder flight, but unfortunately the weather outside is not good to fly it. So I decided to do pretty much a review of what I did to this aircraft, how everything is installed, how everything is mounted, how everything is going to work from now on, so on. Okay, so let's start with the arms. The arms that I got right now over here, they are the ones from the 550. I placed the order from HOVERTHINGS, and nice person that works from HOVERTHINGS. She was very helpful. He helped me, obtain these arms. Her name is Becky. So thanks to you, Becky, for a great service, and thanks to HOVERTHINGS too. To get these arms right away and install into my aircraft. Sometimes, you order stuff that you want to buy stuff in there at the moment that you need it or kind of stuff. So they rushed to make the part for me, and here we go. I got it right here. Okay, so the arms that are longer, these arms that are designed to work not only on a quadcopter, they are designed to work on an XA aircraft. And an XA aircraft is an aircraft that uses 2 motors per arm. So in other words, I could have this aircraft set up with 8 motors, one in the top, another one in the bottom, and the one in the bottom would be the aircraft would be aircraft with counter rotating set up on each arm. Okay, so we'll have one motor spinning to one side and the one on the bottom spinning to the other side. And that's how it will be. But means of doing that, I decided to just put more powerful motors than the ones that I had, and put the motors with bigger props. So that way I can get more. Give the aircraft more capabilities of carry heavier payload and make the aircraft more stable than the way it used to be before with the previous motors and the previous props. Okay, so the motors that I got right now, as I mentioned on the previous video, are the Exceed RC rocket motor, and this one is the 2215 740 kV motors. The nice thing about these motors versus the one that I had before is these motors, they can work either on 11.1 volts or 14.8 volts, and one of the biggest upgrades of this motor versus the previous one is now these motors, they do come with Japanese made ball bearings, so they are designed to last longer. And I dealt with Japanese made ball bearings before, and they last great. They're truly whatever. They are great little barrels. Okay. This is the motor that I had before. This is the prop that I had before. So you can see the motor is about the same size, and no matter if it's the same specs. The only difference, this motor can only take 11.1 volts. And the props that I got over here in this motor, they're smaller than in the new motor. This motor, according to the specifications, they can take a prop all the way up to 13-inch prop, and the one that I have right now is a 12-inch, and the one that I have with the motor that I had before is a 10-inch prop. Okay, so you can see the difference between one and the other. Okay, let's talk about the ESCs. That is another part that is installed on the arm. So the ESCs that I got over here, they are the Castle Creation Thunderbird 54 ESCs. They are 54 amps. Now the motors that I have doesn't really need an ESC that powerful. This motor would have worked fine with 36 amp ESCs from Castle, the Thunderbird 36. But I decided to put the 54 because I'd rather have an ESC that is going to be more powerful than the motor that is handling, that had a motor and an ESC that are matched to work with each other. So that way I can push this aircraft a little bit further. I can put more load in the ESC, since the motor is not reaching the limits that the ESC is designed to. The ESC will work more relaxed. This is the ESC is designed to handle motors more powerful than the ones that I have. Okay, so that's why I decided to buy more powerful ESCs. And by buying these ESCs, they are not really affecting the aircraft in any way, since they are about the same size as the 30 amp Chinese ESCs that I had over here before. They're about the same size, they probably weigh the same. Both these ESCs, they are more powerful, and the best part is that these ESCs, if I want to do any settings, all I have to do is just plug it to my computer, and I use the Castle Link software to program the ESCs, or I can use the programming card that will be named the Castle Field, the airplane version, so I can program these ESCs that way, rather than do what I used to do with the Chinese ESCs, that you kind of have to learn like a Morse code to go through the software programming and everything and set it up in that way, and that thing sucks. That's why in these days people don't use Morse code anymore. They use phones. Phone kill the telegraph. So the same way, these ESCs can be set up with a computer while I'm gonna waste my time with listening to beepings. You know, that's ridiculous. You know, so that's why I decided to buy these ESCs. Now the final thing that I want to talk about, the arms, is the markers that I put to this thing to help me with the orientation of the aircraft, to tell me which the front is, which the back. Okay, so in the front I put yellow, orange ping pong balls, and these ping pong balls I bought it at a sports store, and in the back I put white ones. Okay, so you can see got whites in the back and the orange ones in the front. Okay, so it's going to be really easy to distinguish from the distance, you know, which direction the aircraft is going to. Now the way that I did attach these balls on the aircraft, like I mentioned before, these arms are designed to carry two motors, one in the bottom and one in the top, since this aircraft was designed to work with 8 motors, like I mentioned before. So these are the old arms, and you can see that there's like these 4 holes. This motor mount is identical to the motor mount that I got on this arm. So there's a motor mount on the bottom, and you got these 4 holes. So I poke 4 holes on the balls with body reamer, like the body reamers that you use on on the body of the RC cars. I put 4 small holes, like around pretty small, probably like a 4 millimeter, of size, and then I use 2 zip ties, and I wrap around the zip ties around the holes on the ball and around the motor mount, and these 2 zip ties are securing. That's how I'm securing these pinhole holes. I know sometimes people, they use like a lightweight aluminum or plastic rod, and then they put at the end of the rod, they put the ball. But I just decided to put it there, so that way I can give the purpose of that motor mount in the bottom that's not being used for nothing. Okay, and I like the balls to be rather than clear, and so that way it won't be in the way of the propellers when they're sending the air down. There won't be more stuff blocking the airflow. Okay, so that's pretty much everything that I did related to the arms. Now let's talk about the center plates of this aircraft. Okay, let me just put the aircraft over to the side. Okay, so as you can see, this aircraft doesn't have only one single deck with 2 center plates. I got 3 decks and 4 center plates. Okay, so the reason I did that is because like many other people that build do-it-yourself quadcopters, this allows me to install more hardware in the aircraft, since I'm planning to do FPV flights with this aircraft and take aerial videos. Okay, one of the problems with when you choose flight controllers with this aircraft is some of them, they are like these open circuit boards, and they tend to be kind of big, and when you mount that type of flight controller on the center plate, there's no space to mount the receiver unless you got like a really small receiver. Okay, so that's one part I decided to put 3 plates over here. Now, instead of putting the flight controller in the top, like most people will do on their quadcopters, I decided to put it over here in the bottom, and also to make possible to install all the wires and all the stuff that goes in top, connected to the top of the flight controller. I also purchased spacers that they are longer than the average spacers that they come with the aircraft. The average spacers that I got over here, they are like around probably like a 3/4 inch, and the ones that I got in the bottom, they are like an inch and a half long. But also they are a little bit thicker, the ones in the bottom. But the screws, they work with the same screws. They work with 440 standard size screws. Okay, so the same screws that are using the rest of the aircraft that are working with these stand-ups. Now this stand-up spacers that I got over here, it's not like something that I purchased on eBay or any Home Depot or anything like that. I found this on a store named Ranger. And that store, they sell equipment for. It's like a supplier for. They supply like industrial parts, equipment, raw materials, and everything. So they do have all these little weird parts that you normally you find that they are really impossible to get. They have it right there. They got raw materials and everything over there, so that's a nice place to go and get the stuff that you need. So that's why I purchased it, and they are really lightweight. Each of these stand-ups, they only weigh 3 grams, so all 4 together they are only 12 grams, so that's nothing on this aircraft. The flight controller that I got over here, it's the free flight flight controller. Is the FF, and this flight controller, besides being a flight controller, is also it comes with a gimbal camera mount controllers, so you can also hook, two-axis gimbal camera mount to this, and it will be able to keep the camera level. So you got the outputs for that, and you get all that for only $50. And the beautiful thing is the software that you use to program and set up this flight controller through the computer is easy. It's a straightforward to install. It's as easy as just installing, like a hardware. Let's say you buy like a webcam from Logitech or a printer from Hewlett Packard. You don't have to do anything crazy. All the ordinary, the software is easy to install, and it's straightforward and easy to understand. The only thing that I can criticize about this flight controller is the instructions that you download. They are poorly translated from Chinese to English. But you can go to the forums online, and you can find people that they improved the manual, and the manual is written in proper English, so it's really easy to understand and easy to follow. Okay, so the most critical thing on this is calibrating the board to the radio, but other than that, everything is just walk on the park. So it's really easy. Okay. Another thing that I did down here is related to the flight controller and the camera mount is that I put this small 3-inch extensions that they're coming from the board to the servo connectors. So I got one here, and I got another one on the other side. Since this two-axis gimbal camera mount, we got 2 servos. And if I decide to fly without taking any videos, I can just remove this camera mount, and I can just unplug it from here rather than unplug it directly from the flight controller. So it makes things more easier for me. The other thing is, since this flight controller, like I mentioned before, you can do all the settings through your computer, your Windows PC computer. It came with a USB adapter, and it came with a long ribbon cable that you connect to the board and to the USB adapter. The problem with that is that if I wanted to program this particular flight controller, I will have to remove this lower plate off and then plug the flight controller to the long ribbon cable, so that way I can hook it up to the computer. So what I decided to do is I left the ribbon cable, and you can see part of the cable over here. It looks like a freaking little rainbow because it got all kinds of colors. I left it permanently installed on the aircraft. You can see part of the ribbon cable over here too, and the connector is right here. So when I need, you can see I'm moving the connector right now. So if I want to do any kind of settings on the flight controller, all I have to do is just plug the connector there, plug it to the computer by using a USB cable, and I will be good to go. And when I'm done, I just unplug everything, but the wire stays in the aircraft, so it makes my life easier. Now let's go back over here. This is the back of the aircraft. As you can see, these are the 2 little bolts, and over here the 2 little white bolts, that's the back. Over here I got auxiliary power wire, and this is a JST wire, a connector that is going to power the FPV transmitter when I decide to fly FPV with this. And you can see that I got 2 battery connectors over here, and the reason of that is because this aircraft, I set up the power distribution board to work either with 1 single battery or to work with 2 batteries in parallel. And parallel means that the voltage is going to stay the same. Even if you're using 2 batteries, the voltage is going to stay the same, but it's going to duplicate the milliamps. So if you got 1 single battery that is a 2000 milliamp, if you use 2 batteries in parallel, the voltage of the 2 batteries will stay the same, but the milliamps is going to duplicate to 8,000 milliamps. So that will be, 8,000. 2,000 by 2 is 4,000. So it would convert your battery into 4,000 milliamps. Okay, so that's the way it's gonna work, and that's the nice thing of having parallel. So you can see the upper plate, it got Velcro, and that's why I got a single 5,000 11.1 battery in the top. But also I got in the plate that holds the flight controller, I got Velcro over here too, and I got the other battery connector. I could hook a second battery over here. Of course, I'm not going to put two 5,000s because I think that would be too much weight for this, but I could probably mount like 2-3,000s. That will increase the flying times tremendously. Probably I might be able to fly for like 17-18 minutes, and it's gonna, the aircraft is, pretty much that's it. You want to fly for a longer time, so that's what it's gonna do. It's gonna increase the flying time. So that's the idea of flying. Have the option of this particular aircraft of flying parallel. Okay. In the center, I got the power distribution board, and I decided to use that. It looks it got the same dimensions like the flight controller. It's like 55 millimeters by 55 millimeters. I believe that's the size. It's like a universal size. All these open circuit flight controllers on the market, pretty much all of them, they've been built the same way. So the nice thing about using that is that it's easier, it's more compact. It goes sandwiched between these two center plates, and the beautiful thing is that the model that I'm using, you got holes, so you can put thick wires, like 14 gauge, or you can use really thin wires like 22 or 18 gauge. And so that, for example, like this thin wire that I got over here, this with the small E-OSD connector, is connected on the area with the thin wires that are supposed to go. And this 14 gauge are connected to the holes where this the thick wires are supposed to go. And it's better than using that customized quick connector wiring harness that I was making. At least on this particular aircraft, it's way easier doing it that way. And it's more easier to work and maintain if I have to do anything. If I want to add more connectors, I can just add it because there's more available openings for that. That's what is also powering the ESCs as well, and it's powering the receiver, because the nice thing about this receiver is you can either power it in the old-fashioned way by connecting either if you, for example, got an airplane, the BC of the ESC will power the receiver, or in this case, because it's a quadcopter, the flight controller is powering the receiver, since the receiver is being the flight controller is powering the receiver, since the flight controller is being powered by the ESCs themselves. But the option that I got with this particular receiver is I can power it separately. So the section of the receiver that gets the signal and process the signal, all the stuff, and work with the telemetry, that can be powered separately by connected directly to the battery. So the power distribution board, I soldered a Futaba connector, and that Futaba connector is connected to input. They separate from the servo inputs on the receiver, and that input is for external power. Okay, but that power, like I said, only gonna power the receiver to keep it on and to get the signal. It's not going to power servos. If you connect servos to the receiver, it's not going to power servos. The servos, you still have to send 5 volts on the side, when on the servo side, you still have to send the regular 5 volts that you would normally send there just to power the servos. Okay, so this receiver right now is dual power, and it's an optimal receiver. All the optimal receivers from high-tech, for the high-tech Aurora 9, they are designed to work in that capacity. They can work on single powered, or they can work on dual powered. And supposedly, you guys should check that with high-tech, where I think they can go all the way up to 32 volts. I'm not sure, but like I said, make sure if you connect the battery directly to the receiver, whatever the voltage the battery is plugged to that separate input. I think it's named DPC. That's that separate input. Don't connect the high power where you normally connect the servos and the ESCs, because it's going to burn out the receiver. Okay, that's the way it is. And this is the best part. Since the receiver is getting power from the battery, that means it's getting the voltage that the battery is sending. Now, these receivers, they are designed with built-in telemetry. So without buying the separate telemetry module that they sell for this to connect more devices, more telemetry sensors, like for example the GPS sensor, the RPM sensors, stuff like that. The nice thing about that is this receiver sends to the radio, to the screen, it sends the actual voltage that the receiver is getting. So if, for example, you connect the battery to the receiver the way I just mentioned, you're going to get that voltage on your radio screen. And not only that, you can set up your radio to work. You can set up the light alarm, not light alarm, a voltage alarm on the radio. So you can set up at what point when the voltage of that is getting on the telemetry, the voltage that you're getting on the receiver, when it goes down to a certain point, since the receiver is getting power to the battery, the alarm is going to go off on your radio, and it's going to let you know this time to bring the aircraft down before the aircraft comes down by itself. Okay, so that's the nice thing about that. So right now I got two light alarms on this aircraft. I got one here and another one over here, since I fly in parallel sometimes. But if I got the aircraft really far away, I might not be able to hear the light alarms, but at least the radio is going to be, because the telemetry knows what's the voltage that is getting from the battery. And I set up that voltage alarm on the radio on 10.5 volts. So when the battery reaches 10.5 volts, it's time, the alarm is going to go off, and it's time to bring the aircraft back. So that's the nice thing about that. So like I said, all the wires that's connected to the power distribution board is going to the receiver and sending power from the battery. Also, there are another wire coming from the power distribution board that's going to the flight controller, because the weird thing about this flight controller is that it's not really powered by the ESCs. This flight controller got a separate input, that is this one right here, and it's also hooked up. This cable over here is hooked up. You can see it's red. It's hooked up to the power distribution board as well, because the flight controller works with 11.1 volts, or also can work on 14.8 volts if you're using a 4-cell battery on your aircraft, so on your quadcopter. So that's why, and I set up that way. And these 4 plates I got here, got like a hole in the center, and also the power distribution board got a hole in the center. So instead of having these wires going up and down from the outside of the aircraft, they're going up and down in the middle of the aircraft. So, for example, you see the receiver in the front of the aircraft over here. You can see the wires that they're coming from underneath, and they're just looping, and then they're connected to the aircraft the way it's supposed to be. So I have, like a nice and neat and clean layout of wires, and that's the way I like it. The least wires you see, the better the aircraft look. Okay, so now let's talk about the camera, the 2-axis gimbal camera mount for the GoPro from C Laser Designs. Okay, I had some speed bumps when I purchased this camera mount, and I made videos recently about the ways that you can make this camera mount better. But when it comes to servos, I still beta testing that, and so far the latest servos I put over here, they're still not working perfect, but they're working way better than the servos that I had before. Okay, this thing first came when I bought it from C Laser Designs. I bought it with 3 turnkey servos, because also this camera mount originally it wasn't a 2-axis camera mount, it was a 3-axis, but I just converted it into a 2-axis camera mount. So the servos, they suck, they get it like crazy when you have no power. I took those servos out and I put the servos from the HS55 from High-Tech, and they were almost as bad as the servos that I had before over here, the turnkey servos. Now I put High-Tech HS65, and the version that I put of those servos is the carbonite version, not the Metal Gear version. And because they are carbonite, I managed to keep the camera mount light, because they are not metal, they are carbonite, but at the same time they are almost as strong as metal, the carbonite. So it's doing a pretty good job. And the part that I like is that the camera, even though it's not perfectly smooth, it's running really smooth. So I can't wait to take a flight and test how that thing is going to work. But still, we got some minor jitters, so let me just plug the battery to the aircraft. You can see the camera just moved because it's arming. Okay, now here's the camera, and you can see the camera is still looking forward, and it stayed level. So it's still doing the job the way it's supposed to be. It's really nice. Of course, you know, to get the camera working perfectly, you have to hook up the flight controller to the computer, and you have to do some adjusting on the menu. On the menu, they call it PTC. That I think that stands for pan, tilt, and zoom. So you have to go to that menu, and you have to do the calibration of the 2 servos, so that way it will work perfect. It will point to the right direction, and it will make the gimbal works in the proper way. Okay, so that's why I love this flight controller, because for $50 you get a real man for the buck. Okay. Another thing about this camera mount is that I installed like those little sticky rubber legs that you would put on the speakers, your house speakers. So that way when you put your speakers either on the floor or on the bookshelf, the base doesn't make the speakers start moving away from where it's supposed to be. So those same sticky rubber feet, I put it 4 of them between this bracket of the upper part of the camera mount and this lower tab of the center plate, and that keeps the this bracket and this camera mount mounted, you know, firmly into the aircraft, while at the same time it helps avoid vibration, so the video can come nice and smooth. So that's why I mount that in between these 2 pieces over here. Okay. Now talking about the center plates again. These center plates, as you can see, I got 4. The one in the bottom and the one in the top that then came with no tabs, that's the original plates that came with the aircraft. The ones in the center, I got the lower one in the center is a 4 tab, and the upper one in the center is a single tab. Those ones that were optional. Okay. Now, instead of having 2 4 tablets, I decided to have a single tablet in the top and a 4 tablet in the bottom because I don't really need that many tabs. The most important tab is the one in the front. It's good as you double stack it and you put these spaces, so in that way this can handle better the weight of the camera mount. Either you're using the gimbal or either if you use the regular GoPro camera mount with the tripod adapter, so that way it won't vibrate, it will work better. So that's why I double stack it and I put these spaces over here to make it stronger. Okay, and it really works fine. I really love it the way it performs. Okay, so I guess I just covered everything about this aircraft. I covered all the upgrades and everything. I wish I could fly, but like I mentioned at the beginning of the video, the weather is not good outside. Okay, so the remainder flight is going to be done in a future video. Okay, so please don't forget to rate, comment, subscribe, and share this video with others. And thanks for watching, everybody. Okay, bye.